Continuing on with example 2. So if you read example 2, the key words here are that its rate, the rate of growth, is inversely proportional to its current height. So if we just sort of remind ourselves of the general form of a inversely proportional relationship, so we could say the rate is inversely proportional to the height. So we have some constant k that is the constant of proportionality, and as h gets larger and larger and larger, the rate will get smaller and smaller and smaller. Or to write that in a differential equation, the change in the height given a specified change in the time is equal to some constant k divided by the height of the tree. And then the rest of the text here gives us some information to start with. So when the tree is planted, it initially is 3 feet tall, and at that very moment when it is 3 feet tall, it is growing at a rate of 1/2 foot per year. So the 1/2 foot per year is the rate, and the height is that right there. So we can take and plug in the rate, which is 1/2, and the rate is then equal to k over the height, and the height is 3. And solving for k, we find that k is equal to 1.5. So to get the specific formula that we're looking for, we write the differential like that. We then move all of the h variables to one side, all of the t variables to another side, or the other side. So it looks like this, and then we're going to integrate both sides of the equation. At this point, I'm going to stop. I'm not going to take the square root of both sides, because what I need to do is I need to find c, and to find c I'm going to put in a value for t and h that I know, and the value for t and h that I know is that right here, that the tree was 3 feet high when it was planted, and when it is planted is called time 0. So if I plug in 0 here and 3 there, what we find is that the c is going to be equal to 3 squared, or 9, which then gives us the following function that will relate the height, give us the height of the tree if we are given the time in years after the tree is planted, which looks like this. You give me the time in years, I'll tell you how tall the tree is, and it's a square root function. Square root function, when graphed, generally looking like that. So at the beginning of the tree's life, it's growing quickly, and as it gets towards taller and taller and taller, the tree slows down. And we're done with example 2.